Hello and welcome to today's maths lesson. My name is Robert and it's great to be here. It's great to be able to do this. It's great to be able to bring learning into your home. And in today's lesson, we're going to be talking about analytical geometry. Now, a question that I always used to ask myself in school is there a link between specific sections in mathematics, and particularly today, is there a link between geometry and algebraic equations? Now, the answer is yes, and that answer is analytical geometry. Now, analytical geometry is really cool because we can solve algebraic questions geometrically, or we can solve geometric problems algebraically. Analytical geometry is pretty much just points, lines, angles, shapes within a Cartesian plane, the Cartesian plane that you've used for functions and transformations. Now, what's also nice about analytical geometry is that analytical geometry is the foundation of a significant portion of engineering, physics, aviation, rocketry, and some really cool things. Now, I'm going to jump straight into what we're going to be talking about today. And today we're going to be talking about, amongst other things, distance. But before we get into distance, what's important to know is what is a point. Now, we spoke about points in functions and transformations on a Cartesian plane, and we spoke about a coordinate pair. So here I've written a coordinate pair, 2, 3 in brackets with a semicolon in between. The first one, or the first number, is always the x-coordinate, and the second number is always the y-coordinate. So if I have a whole bunch of points, here I've got A, B, C, D, I've gone and plotted them. We can see that A, the x value is 1, and so if I find x, or 1 on the x-axis, and 1 on the y-axis, where do they meet up? Well, they meet up at this point, and therefore that is A. B, the x-coordinate is 6, well, that's here. The y-coordinate is 1, that's here. And where do they meet up? Here at B. Now, I've also plotted C, and I've plotted D, and I've joined them up into a rectangle. But what's important to remember when talking about quadrilaterals is the ordering of the letters is important. So if I had spoken about the shape ACBD, we always follow and draw the lines in the ordering of the letters. So here I would go from A to C, to B, to D, and back to A. And that's not a quadrilateral, that's not a rectangle, that's some sort of bow tie. And so what's important is that we always follow in the ordering of the letters. And so this is specifically why I've written A to B to C to D. Now, moving on to distance, when we talk about distance, distance is just the length between 2 points. And we're going to be working on the Cartesian plane. And so when I look at the Cartesian plane, here I've gone and plotted A and B. And the distance between them is different on my screen than it is potentially on your TV and someone else's cell phone. And so we can't talk about centimeters because everybody's got a different representation or size on their screen. And so what we're going to be talking about is blocks. So here we can see from A to B, I've gone 5 blocks. Now, the word we're going to be using is not blocks, it's going to be units. All right, and we're going to be talking about 5 units, and that's important because 5 units on your screen, or my screen, or someone else's screen is exactly the same. Now, when we talk about the distance between A and B in this sketch, this is a little bit more complicated because can everybody see? I can't really see how many blocks there are between A and B because it's not perfectly linked up. So the way that we're going to be doing this is we're going to be using Pythagoras. Does everybody see that if I go and make a right-angled triangle, right, I can see how many blocks there are there, and I can see how many blocks there are here, and I can use the theorem of Pythagoras to calculate the distance of a diagonal line. And so what that brings us to is the formula for distance within analytical geometry on a Cartesian plane, and that formula is this. If I have 2 points, A and B, the formula that I'm going to be using to calculate the distance from A to B is going to be the square root. I'm going to open brackets. I'm going to take the x value from the first coordinate, A. I'm going to subtract the x coordinate of the second point, and I'm going to square that. And then I'm going to add, I'm going to open brackets, and I'm going to take the y coordinate of the first point. I'm going to subtract the y coordinate of the second point, and then I'm going to square that. And that's going to give us the distance. That's going to give us the number of blocks or units diagonally or horizontally or vertically between 2 points. Great. So that's where we're going to go to an ad break, and we'll see you now. Cool, welcome back. So we're going to jump straight back into what we were talking about beforehand, before the ad break, which was analytical geometry and specifically distance. Now, the formula that we had got to through Pythagoras, the vertical distance and the horizontal distance, which we then used to calculate the diagonal distance, was this formula where we took the first x value, we subtracted the second x value, we squared that, then we added the first y value minus the second y value, we squared that, and then we square rooted that, and that was the distance. That was the distance in blocks or in units between 2 points, horizontal, vertical, or diagonal. Now, we're going to do some questions. And for these questions, it would be great if you could do them with me. So maybe take out your calculator and do it on your calculator when I do it on the calculator, and then we can see how this plays out. So here they've said, use the distance formula to calculate the distance between point A and point B. In a test, they're not going to say use the distance formula. They're just going to say calculate the distance between points A or B. Or they might ask it in another context, and we're going to talk about examples like that as we go on. But specifically now, we're just starting super simple, and we're calculating the distance between points A and points B. So if I look at point A and point B, the distance between A and B, I'm just going to do the formula, and the formula was the square root, open brackets. I'm going to take the first x value, and I'm going to subtract the second x value. I'm going to close the brackets, and I'm going to square it. That 4 is not the best 4 that I've drawn, but it's hopefully legible to you guys. Then we're going to take, I'm going to add, I'm going to open brackets, and then I'm going to take the first y value, and I'm going to subtract the second y value. Now, again, remember when we did substitution in grade 8 and 9, it was important that when I subtracted a negative number, I put that in brackets, because it's too easy to just write minus 3. It's not minus 3. What this is, and let me erase that, this is minus 3. Which ends up becoming a plus. So what's important here is that when you subtract a negative number, you put it into brackets so that you don't make that mistake, and then I'm going to square that. Now, I could simplify this piece by piece, but that's going to be a mission. So what we're going to be doing is we're going to be using our calculator. So take out your calculator, do it with me. I'm going to choose my calculator on my screen here. And I'm just going to put what's on the board straight into my calculator. So I'm going to choose the square root. I'm going to open brackets, and I'm going to go 1 minus 4. Oh, I did 2 4s. Close brackets. I'm going to square it. I'm going to add, open brackets, 2 minus. And again, this is what we're talking about when we talk about minusing a negative. I want to open brackets again, negative 3, close brackets, that's for the negative 3, close bracket, that's for the y values, and I'm going to square it, and I'm going to get an answer like, oh, and sorry, let me go back there. I lost my line there. The answer that we got, and let me go back to the calculator, was the square root of 34. So the answer, let me choose my pen, is the square root of 34. Now, what is the square root of 34? If we go back to the calculator, if you have this calculator, there's this button SD, and if I press that SD button, I get 5,83. And let me go back here, choose my pen. This is equal to 5,83 units or blocks, remember, like we discussed. Now, we're always going to leave it in the square root form. We call that the surd form. Right? We're always going to leave it in this form because this form is rounded off. And when we move forward, when we use this in question B or question C, and we use the rounded off value, we might lose accuracy. And so specifically, we're always going to leave it in this form, the square root of 34, like the calculator gives it to us. So if it gives it to us like that, the answer is 5,83, but I'm going to leave it as the square root of 34. Okay, so pretty simple. I took my x values, I took my y values, I plugged them straight into the formula, and I got my answer. All right, so we're going to move on to the next question. I would want you guys to practice some of these questions at home. We are going to make it a little bit more complex now, but practice some of the really basic ones. Make sure that you know the formula. The formula will always be given to you, but make sure that you're able to use it and apply it and get it right. Okay, so here it says, use the distance formula to calculate the distance between this point C and this point D. Now, does everybody see this question is a little bit more complicated because we don't actually have values. We have algebraic kind of letters, values. And so the way that we're going to be doing this is not different. And that's the point, is we're going to be doing exactly what we did with the numbers now with the algebraic values. Okay, so again, I look at this, it looks a little bit strange. I don't exactly know what to do, but let's just use the formula and see what happens. All right, so the distance, they wanted us to calculate the distance between C and D. So the distance between C and D is always going to be the square root of the first x value, x, minus the second x value. All right. But when we do this, it's important that what I've done here, and you can see on the screen here, what I've done is I've subtracted the x. All right. But I didn't subtract the 4. I just added the 4. All right. But I want to subtract all of it. I want to subtract the whole x coordinate. I want to subtract x plus 4. And so let me just erase what I did there. What I want to do to make sure that I subtract x and 4 is I'm going to put that in brackets. And so actually let me go back to the start here and make that a square bracket, and I'm going to put this into a round bracket so that I remember what I'm doing there is I'm subtracting the whole x coordinate. I'm subtracting x and 4. Then I'm going to add, and again I'm going to use square brackets here, and I'm going to do the y coordinate y minus the y coordinate there, and I'm going to again put it in brackets because I'm subtracting all of it. I'm not only subtracting the first part of that y coordinate. And this question suddenly becomes a whole lot more complex because I can't do it on my calculator. But it's not hugely more complex. All we're going to do is we're going to work through it step by step. We're going to use the rules that we've learned in previous grades, and we're going to get to the answer. All right, so we're going to simplify this a little bit. What I'm doing here is I'm subtracting x and I'm subtracting 4. And so what I like to do is I like to always put a minus 1 in front of the brackets because I'm going to be distributing that minus 1 in onto the x and the 4, and I'm going to get minus x minus 4 all squared. And for the second one, I'm going to be distributing that in, and it's going to be y. Minus 1 times y is minus y, and minus 1 times minus 1 is plus 1. And this is great, because now what we can see is the x coordinates cancel out, and all I'm left with is a minus 4 squared, and I'm left with a 1 squared. I forgot the squared there. And at this point in time, I can go back to my calculator. I don't have algebraic letters anymore, so I can go back to the calculator, I can plug it into the calculator, and we can get an answer. And so let's do that. Let's go back to our calculator. I'm just going to start that again. Cool. So the square root, and I open brackets. It's important that I'm squaring the minus 4 and not just the 4. So I'm going to put brackets there. I'm going to go minus 4 squared. I'm going to add, and I'm going to add 1 squared. And the answer that I get is the square root of 17. And so my answer is the square root of 17. It looks strange because I had algebraic values, but when I put it into the formula and I worked through it step by step, I got to my answer quite nicely. Awesome. So we're going to work forward and we're going to do the next question. Here they say calculate or determine x. So this is what they want us to determine. If the distance between these 2 points, CD, is equal to 5 units. Now, what we're doing is we're doing it backwards. All right, so what we did in the past, on the previous 2 examples, is I gave you the 2 coordinates and we had to work out the distance. Now, I'm giving you the distance and I want you to go work out what are those 2 points. Now, I have most of those 2 points, but I don't know what x is. And so this is just a simple equation. I just need to put everything in, put in the answer, and then work backwards and try figure out what x is. Now, what I always find is very, very helpful in a question like this is drawing a sketch, trying to visualize what is actually happening in this question. And so what I've done is I drew a sketch, and I put C on the sketch. C is down here at x value of 6 and a y value of minus 2. Now, I don't know where D is, but I do know that the y value of D is equal to 2. So this point here is 1, 2. And this point here is 2, 2. And this point here is 10, 2. I don't know where my point is going to be, but I do know that it's going to be somewhere on this line because the y value has to be 2. And so what I did is I drew another sketch, and what we can see here is that I've just drawn the line with all the points where the y value is going to be 2. All right, so now I somehow need to find where must I put D so that the distance is 5. All right, is it directly straight up? Well, no, because if I go and draw in the values on my y-axis, does everybody see that this is just 4 units? All right, so it has to be a little bit more than that. So it has to be a little bit diagonal, and so it must be there. All right, D must be somewhere there. But is that the only value? Can't it maybe also be there? That's 5, but this is also 5. And so it seems like in this question, I'm going to get 2 answers, all right? 2 x values for that point D where the distance is going to be 5 units. Now, I've spoken a lot, but let's just actually do the question. Let's start. So I've put my sketch to the side here so you guys can see it there. All we're going to be doing is let's just plug in the values into the formula, put it equal to 5, and somehow try solve that equation. Again, I don't know quite where that's going, but let's just start and let's just see where that goes. All right, so I'm going to put in the values. I know that the distance between C and D is going to be the x value of the first point minus the x value of the second point. So it's going to be 6 minus x, and I'm going to square that. Then I'm going to add, and I'm going to go the y value of the second point minus the y value of the first point minus the second point. I'm going to square that. And this is not complete because I've written here CD, but I know what the answer to CD is. I know what the distance is. The distance is 5, and that's the crucial part here is I don't know everything that goes into my formula. Specifically, I don't know what that is, but I do know what the answer is. That answer there is equal to, oh, sorry, let me go back to my pen. That answer there is equal to 5. Cool. So what we're going to do is we're going to solve this. I want to get x alone. Now, there's a whole bunch of stuff stopping x from being alone. Firstly, the square root. And so I'm going to square both sides. Remember when we discussed equations, everything was legal if I did it to both sides. All right? And so that's what I'm going to do is I'm going to square both sides. I'm going to get 5 squared, which is 25. If I square a square root, they undo each other, and so I'm just going to be left with 6 minus x squared plus minus 4 is going to be, minus 2 is going to be equal to minus 4. I'm going to square that. And does everybody see that now I've reached an equation that is fairly similar to the equations that we saw in grade 9? So here I'm going to FOIL this out. This is just going to be equal to minus 4 squared is 16. Here, and this is so crucial, please don't make this mistake. This is not equal to 36 minus x squared. It's not equal to this. Remember the way that we did this is what we did, and let me erase the thing that I did wrong. The way that we did this is we wrote out the bracket twice, like that. And then we did FOIL. We did the distribution of multiplication, and we went 6 times by 6 is 36. 6 times by minus x is minus 6x. Minus x times minus 6 is minus 6x. Minus x times minus x is plus x squared plus 16. And this is just a quadratic equation. I just need to clean it up a little bit, take everything to one side, and get an answer here. So let me do that. Here I'm going to get x squared. Here I've got a minus 6x and a minus 6x. That's going to give me minus 12x. Here I've got a 36 and a 16. All right, that gives me a plus 52. And on this side, I've still got a 25. Remember when we do quadratic equations, I want to take everything to one side equal to 0. So I'm going to take the 25 to this side. That's going to give me 47. That's going to give me plus 27. All right, and this I can factorize as x minus 9 and x minus 3. Sorry, I did that quite quickly because my time is running out. And then what I end up with is x is equal to 9 or x is equal to 3. And that makes sense because there is 6, here is 9 somewhere, and so there's going to be my second answer, and here at 3 somewhere is going to be my first answer, both of them having a distance of 5. In the previous lesson, we spoke about distance, and we just spoke about distance for the sake of distance. Now what we're going to be doing is we're going to be linking distance to shapes. And so this is going to be a multi-step question, and we're going to see how this goes as we go into the question. So the question we're going to be doing goes like this. It says they've given us 3 points. They've given us M. Oh, sorry, let me go forward and choose my pen there. So they've given me this point M, which we can see down here. They've given me N, and they've given me O. So I've got a little bit of a triangle there. And what they want us to do is, firstly, and we're going to move on to the second part of the question now, but they want us to firstly calculate the perimeter of that triangle PQR. Now, we know that the perimeter is the sum of all the lengths of all the sides. So they haven't asked me to work out the distance of each side, but we know that this is the way that we're going to be doing this using the distance formula. And so I'm going to jump straight in. They want me to calculate the distance of all the lines, and so I'm going to jump in by first calculating the distance between M and N. And so the distance between M and N, we've done this a few times now, is going to be the first x value of M minus the x value of N, in brackets, squared. Again, this formula will be given to you on the formula sheet, so it's just plug and play. I write down the formula, I put in the values, and then I'm going to take the y value of M, 1, I'm going to subtract the y value of N, 4, and I'm going to square that. And again, I could try and do this in my head, but there's so much room for careless mistakes there, so rather just take out your calculator, put it into the calculator, and let's make sure that we get this right. So if I put this into my calculator, minus 1 minus 5 all squared, then I'm going to add, I'm going to open my second bracket, and I'm going to go 1 minus 4 all squared, and I'm going to press equals, and the answer that I get is 3 and the square root of 5. So I've now gone and calculated this distance of MN. That distance there, I've drawn it on my sketch, is 3 root 5. I haven't got the full perimeter, but I've started and I'm getting there. So the next thing, and I've drawn it, that distance there, is I'm going to calculate the distance between N and O. So again, I'm going to use the formula. I'm going to do the x value of N. I'm going to subtract the x value of O. I'm going to square it, and then I'm going to add the y value of N minus the y value of O. I'm going to square that. Again, I'm just going to put this straight into my calculator. So I'm going to go open brackets, 5 minus 6, close brackets. I'm going to square that. And then I'm going to add, I'm going to go the y values squared. And then I'm going to get an answer, and that answer is the square root of 5. Again, what is the square root of 5? The square root of 5 is actually a value. And let's go back to that calculator. This button there, SD, it means third to decimal. So if I press this button, it's going to change from the third value of square root 5 to the decimal value. And what I get there is 2,23. If I round that, it'll be 2,24. So it actually has a value. We've just written it as square root of 5 so that we maintain the accuracy so that we don't have to round off. So let's go back. I've now calculated the distance of NO. That distance is the square root of 5. And similarly, I can work out the distance of MO. And the distance of MO is 5 root 2. All right, using the distance formula, I can work out that distance 5 root 2. And then I can go, and they've asked for the perimeter, and so I'm just going to have to add these. So I'm going to go 3 root 5 plus the square root of 5 plus 5 root 2. So I'm going to go back to my calculator, and I'm going to put it in, and I'm going to calculate it. And so let's go 3 square root 5. I'm going to add square root 5. I'm going to add 5 the square root of 2. I'm going to press equals, and the answer that I get is that. Now, because that is not one thing, because it's two terms, because I'm adding two things, I am actually going to go SD, and I am actually going to write down, oh, sorry, let me go back to that. I am actually going to write down the decimal value of that. And so the answer that I got there was 16,02. And so the perimeter of this shape is 16,02. Now, I hope everybody understood that. If you didn't, we are going to do similar questions as we go on. So again, this is a multi-step question, and so we're going to move into part B of this question. And part B of this question says, show that this triangle is a right-angled triangle. Now, we could potentially use trigonometry to do this, but say we didn't know anything about trigonometry. What I do know, and what I do know from grade 8 and 9, is that if I have a right-angled triangle, this means I can use Pythagoras. Right? So if it's a right-angled triangle, I can use Pythagoras. Alternatively, if Pythag works, if Pythagoras is true, then it must be a right-angled triangle. There's no other option. All right? So what I'm going to do is I'm going to go do Pythag. I'm going to go the short side squared and the short side squared, and I'm going to see if it's equal to the long side squared. If it is, then it must be a right-angled triangle. And so I'm going to erase all of the stuff that I've written on the board. And we're going to do exactly that. So I know that Pythagoras is the short side squared plus the short side squared. All right, and so that's what I'm going to do is I'm going to go the one short side squared, and I'm going to add the other short side squared. I'm going to take out my calculator. I'm going to put this into my calculator. I'm going to go 3 square root 5 squared. Oh, what happened there? Let's go back. 3 square root 5. I'm going to square that. I'm going to add the square root of 5 squared. And what I get is, what I get is 50 units. Now, if the long side squared, and the long side is also known as the hypotenuse, if I go and calculate the hypotenuse squared, well, technically it would only be the hypotenuse if it is in a right-angled triangle. So let me erase that. Right now I can't actually write that that is the hypotenuse. If I go and do this, and I put this into my calculator, I also, and I'm not going to do that, but I'm telling you, and you can check it for yourself, that I also get 50. All right? And so what this means is that the short side squared plus the short side squared is equal to the long side squared. So what we discussed that if Pythag is true, then it must be a right-angled triangle. And therefore, this is a right-angled triangle, and we've proved what they wanted us to prove. Great. So we're going to go to an ad break now, and yeah, I'll see you guys soon. Welcome back. So we're going to jump straight back into what we were doing. So we spoke about distance and how that links to shapes. And we showed that a triangle is a right-angled triangle by showing that Pythagoras is true. Now what we're going to be doing is we're going to be talking about the second thing for this lesson, which is the midpoint. All right. Now, a midpoint is exactly what it says it is. If I look at the midpoint of a line, the midpoint is going to be exactly in the middle. Now, coincidentally, this middle is on the x-axis. It won't always be, and in our first example, it won't be. But yeah, so this is the midpoint of our segment. We can see it there. And what we're going to be doing is we're going to be talking about the formula. Now, the formula is pretty straightforward. The midpoint of a line is always going to be like this. It's going to be the x value of the first one. I'm going to add the x value of the second one, and I'm going to divide it by 2, and that's going to give me the x coordinate of the midpoint. Then, similarly, I'm going to take the y value of the first one, I'm going to add the y value of the second one, I'm going to divide that by 2, and that's going to give me the y coordinate of the midpoint. And so when I calculate the midpoint, it's two calculations. It's the calculation for the x coordinate, and it's the calculation for the y coordinate. And what's important to recognize here, and let me erase all of the ink here, what's important for us to recognize is in the distance formula, I was subtracting the x coordinates, but now what I'm doing is I'm adding the x coordinates and I'm adding the y coordinates. And so please don't make this mistake. Every time that you use a formula, look at your formula sheet, copy down the formula, and use that formula. Like, losing marks on the incorrect formula is, yeah, we can't do that. It's, yeah, we just use the formula from the formula sheet. Let's make sure that we get all the marks where we should be getting it. Okay, so let's jump straight in. Let's use this formula. Let's just jump straight into an example. Here, this example says they want us to find the midpoint of these 2 points, A and B. I've drawn a sketch here, so you can see A down here. I've drawn B, it's up there, and I've drawn my point there, right in the middle. That's the midpoint, and we're going to be using the midpoint formula to find the coordinates of that point there in the middle. Now, we're just going to jump straight in, use that formula. And so what was the formula? The formula said I'm going to take the x value of the first point, and I'm going to add the x value of the second point, and I'm going to divide that by 2. That's our first calculation, but I'm just going to write it down for now. The second part was to work out the y coordinate, and so I'm going to take the y coordinate of the first point, I'm going to add the y coordinate of the second point, and I'm going to divide that by 2. Now, again, specifically when there's negatives here, please just be careful. Let's make sure that we get this right, because there's so much room for a careless mistake to just slip in here. So let's make sure we get this right. And so -1 plus 5, I can check this on my calculator to make sure that I get this right, but that's going to be 4. I'm going to divide that by 2. If I go -3 and I add 7, I'm also going to get 4. If I divide, and I'm going to divide that by 2. And what I end up with is 2 and 2. Great. So I know what? What did this actually give me? This gave me the coordinates of that point there, right in the middle of my line. And what are those coordinates? 2 and 2. And our sketches are not often going to be drawn to perfect scale, but if a point looks like it's going to be in the first quadrant, it is going to be in the first quadrant. And so this answer feels right. It feels right. And that's the nice thing about geometry and analytical geometry, is often the answer, we can logically decide if our answer feels right or feels wrong. And that feeling isn't necessarily going to be right all the time, but it does give us an indication of if we're in the right ballpark or not. Awesome. So let's jump into the second question. Again, exactly like we did with distance, is we started with normal points, and now we worked into algebraic points, and so that's what we're going to be doing here, is the midpoint is going to be the x coordinate plus the x coordinate, and I'm going to divide that by 2. And I'm going to go the y coordinate, and I'm going to add the y coordinate here, and I'm going to divide that by 2. And now that all that remains for me is to simplify. So I can't do this on my calculator. I'll have to do this by going x plus x is 2x, 2 minus 5 is -3, and I'm going to divide that by 2. Here I'm going to get y plus y is 2y, -1 minus 4 is -5, and I'm going to divide that by 2. And at this point in time, I can't simplify it any further, and so this is how I'm going to leave my answer. That there is the coordinate points of my midpoint. So sometimes I'm going to end up with a nice answer, sometimes I'm not. And here I don't, and that's fine. Okay, cool. So let's get into the next question. The next question is a little bit different. In the previous question, what we had is we had the two endpoints, and I had to go find what is this point in the middle, right? If we read this question, they say the midpoint M of PQ is 3, 9. They've given me the midpoint. So it's already different from the previous question, because in the previous question, they wanted us to find the midpoint. All right? And they say find the coordinates of P. They want us to find this if Q is equal to -2 and 5. And so let me go erase a little bit of this so that I can make a little bit more sense of what I'm trying to say. But in the previous question, I started with the two endpoints, and they wanted me to find the middle point. Now this question is different, because in this question, I've got one of the endpoints, I've got Q, I've got the midpoint, I've got M, and they want me to find what is the other endpoint. And so this is exactly like we were doing in the distance formula, where initially I had the coordinates and I was just working out the distance. Then what we did is we switched it up and we said, cool, now I've got the answer and I want to work backwards and I want to figure out what one of those coordinates are. And that's what we're doing here, is I've got the answer and I'm working backwards using the midpoint formula to find what is the other endpoint, so that that point must be in the middle. Okay, so let's do this. What we're going to do is exactly like we did in the distance formula when they gave us the answer. We're going to set up an equation with the answer and with the formula that was given to us. And so they've told us that the midpoint is 3, 9. And so I'm going to say the answer is 3, 9. Then let's say that the coordinates of P, and I'm going to write here, are X and Y, right? So how does the midpoint work? I go the X coordinate plus the X coordinate. I divide this by 2, and that gives me the X coordinate. For the Y coordinate, oh, sorry, that was incorrect. Let me just erase that. I added the wrong X coordinate there. What I'm going to be doing, sorry, I'm going to be working out that X coordinate plus this X coordinate, so incorrect, sorry, that's going to be -2 plus X. And then I'm going to go the Y coordinate 5 plus Y. I'm going to divide that by 2, and that must give me my answer. Now, this, in effect, is 2 separate equations, all right? This first piece there must give me 3, and the second piece in a square must give me that 9, which is in a square. So I'm going to set up 2 separate equations. I'm going to solve it. How do I get X alone in this first one? Well, I multiply both sides by 2. The 2's will cancel, and I'm left with -2 plus X is equal to 6. Then how do I get the X alone? I'm going to add 2 on both sides, or some people use the terminology, I'm going to take the -2 to the other side, and I'm going to get X equals 8. And so I know that the coordinate here is going to be 8. Now, similarly, I can go do that for the Y value. I can set up a second equation here, 5 plus Y over 2 is equal to 9. And if I do that, the answer that I'm going to be getting is going to be 13. And you can check me on that. I hope I did it right, but make sure that that is indeed right. We're going to be moving on to the next question. And this question is going to be exactly like we did with the distance and with the shapes. We're going to be linking the midpoint to a shape. So this question says PQRS is a parallelogram. Now, if I look on my sketch here, I've got P, I've got Q, I've got R, but I don't have S. And so if I were to draw this parallelogram, does everybody see that S would be somewhere here? All right. And they want me to go find the coordinates of S. So they want me to find S. Now, this is where we have to link our geometry concepts into the question. And we're going to have to link the properties of a parallelogram somehow to solve for this question. And if you guys think about a parallelogram, what is a property that I can potentially use to find S? If you guys think about it, one of the properties, and this is the one that we're going to use, is that the diagonals of a parallelogram bisect. The diagonals of a parallelogram split each other in two, all right? And this is great because is everybody happy that I can find the midpoint of this line, PR, I can find what those coordinates are there, and then if I draw the second diagonal from Q to S, I can go find what S is because I know what this midpoint is there, M, because I've already calculated it. And this is what we did previously where I had the endpoint, I used the midpoint to find the other endpoint. And so let's do that. I'm first going to find the midpoint of this line. How did that formula work? Well, it was the x-coordinate plus the other x-coordinate. So it's going to be 2 plus 7 divided by 2. And it's going to be the y-coordinate plus the y-coordinate. 1 plus minus 3 divided by 2. Again, whenever we do substitution, let's make sure we do that in the bracket. And what I'm going to get here is, if I put this into my calculator, I'm going to get 4.5. Oh, I didn't draw that 5 very nicely. I'm going to get 4,5, and my other coordinate ends up being minus 1. And I've just written that down because we are running out of time. 4,5 and 1. All right. And now what I need to do is I need to find the other endpoint using the endpoint and the midpoint. So let's do that. Let me erase a little bit of what I have here so that we have more space. Awesome. So I know that the answer is 4,5 and 1. I know that I'm going to go the x value plus the x value. And so I'm going to go 5 plus x divided by 2. And I'm going to go the y value plus the y value divided by 2. And that needs to give me 1. And then I'm going to set up two separate equations. 5 plus x divided by 2 is 4,5. And then I'm going to go this y value, 3 plus y divided by 2 is equal to 1. Those are two separate equations. I'm going to solve for them. And you can finish this question at home. I've done most of it. And then we can find that last coordinate of our parallelogram. Awesome. So that's all we have time for today. Sorry that I had to cut that short, but it's been great. Thank you so much for spending this time here, for learning, and yeah, we'll see you next time. Bye.